Let's look at Savannah Hilton Head Airport, and specifically at the ILS or LOC approach to runway 10. There are two major chart products depicting the same procedure, as well as all others in the US. There's the FAA plate, which you're likely familiar with having done any instrument flying, and then there's the plate published by Jeppesen. Though Jeppesen plates are a subscription service while FAA plates are distributed free of charge, almost all commercial carriers use Jeppesen exclusively. As we compare the two, you may see some clear advantages Jeppesen has that make it the preferred choice of the pros and why it can improve flying within the general aviation community as well. This is Dan from FlightInsight, partnering with ForeFlight on a series of videos highlighting the Jeppesen chart products and how they integrate with ForeFlight Mobile to make your instrument flights safer and smoother. Let's look at the key differences between the FAA and Jeppesen plates. First, let's have a closer look at the top portion of the Jeppesen plate. This is the briefing strip, which, as we stated in our last video, lays out information in such a way that pilots should be able to brief the entire approach by reading from top to bottom, left to right, entirely within this area. Further down, you have notes and restrictions, and you have minimum safe altitudes on the right. So we could brief the full ILS approach 10 into Savannah by just moving through the briefing strip. Let's compare this process with how we'd get the same information on the FAA plate. It starts off alright with the communication information reading left to right on each plate, but then it starts to get a bit convoluted on the FAA chart. Here's the localizer and approach course up here, then down below is the glide slope intercept, then the ILS minimums, back up top for elevations, over here for the missed approach, back to the left for notes, then down in the plan view for the minimum safe altitudes. Jeppesen has streamlined the briefing process for the busy environment of the cockpit. Next, let's have a look at the plan view and see what's different there. First of all, Jeppesen depicts nav aids a little differently. Here's the Savannah VOR, which is used in the missed approach procedure. Notice the difference between the hexagon the FAA uses and the compass rose in the Jeppesen plate. Also, the primary nav aid used for lateral guidance, in this case the localizer, is shown a bit differently by Jeppesen. This helps distinguish the localizer from other nav aids like that VOR. On the FAA chart, the only distinction is a bolder line around the localizer info box. Looking at the approach course, you see that the distance information is displayed a little differently. The FAA plate uses an elongated D to show DME, while the Jeppesen plate just has an uppercase D before the distance figure. The holding fix on the missed approach procedure is depicted very similarly in both plates, though the racetrack pattern looks a bit different. FAA charts use bars above and below altitude and speed figures to show restrictions. Here, at the initial approach fix Tilly, there's a maximum 6,000 and minimum 2,600 holding altitude. The Jeppesen plate just depicts these restrictions textually. Here's a neat thing the Jeppesen plate does. It has a block arrow showing the highest obstacle on the plan view. There's actually two on this approach, of an equal MSL height of 1,548 feet. Next, let's look at the profile view. The Jeppesen plate doesn't include an airport diagram like the FAA plate does, so it uses the extra room to show more detail on the approach profile. First, let's see how the Jeppesen plate depicts missed approach points. There's a so-called pull-up line here for the decision altitude on the ILS, and a line here for the minimum descent altitude missed approach point for the non-precision localizer-only approach. Notice the FAA plate uses lines below the altitude restrictions to show them as minimums. On the jet plate, you'll have to know that since it's an approach, these altitudes are floors, not to go below. One thing the jet plate adds that I think is also very valuable is what your rate of descent is in feet per minute to maintain a 3-degree glide path. When flying the non-precision localizer approach here, knowing your descent rate for a given ground speed can help you plan a continuous descent on final approach. You'd have to do some mental math or look this up elsewhere if using the FAA plates. Let's have a look now at the minimum section, where things are laid out a bit differently on the two plates. The minimums are read from category A through D. On the FAA chart, this moves from left to right, while on the Jeppesen plate, they go from top to bottom. Here, you see how each plate depicts the altitude and visibility minimums for the ILS approach. For all category aircraft, the decision altitude is 230 feet with a visibility minimum of RVR 1800. The Jeppesen plate has an important addition here though. Notice the headers full, TDZCL out, and rail ALS out. The visibility minimums change with inoperative equipment, and typically get worse as you read from left to right, starting with full equipment operation, going to the touchdown zone and center lights being out, And finally, the highest mins when the runway end identifier lights and approach lighting system is out. This is something almost completely missing from the FAA plates. These alternates are standard for equipment outages, but you'd only be able to find what they are in the FAA's in-op components section in the terminal procedure publication, not something you're likely to have handy on a real-world flight when the ATIS advises something isn't working. Let's look at the localizer minimums to see how this works again. For Cat A and B aircraft, the MDA is 500 with RVR 2400. But if the rail or ALS is out, we go up to RVR 5500. Finally, on the right, we have the circle to land minimums for each category. So while almost everyone starts out with the FAA charts because they don't require a subscription, commercial operators have long recognized the extra value to be had from Jeppesen plates. Being able to download and integrate them into ForeFlight means that the General Aviation pilot can also leverage the added situational awareness and ease of use that they offer.